FreeBSD with whatever 5 other packet filters you guys support. And MapBSD, macOS, a bunch of other platforms. I'll talk about that a little bit later. I've been doing PF hacking for 9 years now. I started about 1 year before I became an OpenBSD developer doing IPv6 support for PF. And that made me so crazy I didn't want to touch it for a while. But then after about a year, I did some more hacking, and they forced me to become a developer because they didn't want to commit my diffs for me anymore. Nobody else wants to touch v6 code either. So there's actually more than 68 problems with PF. Those are just the ones that are documented in the code. So PF is the standard BSD packet filter. It was started in 2001 after we removed IPF from the code. The author of IPF decided that he wanted control over us making changes to the code. So it doesn't meet the licensing requirements of OpenBSD anymore. And we removed it without even having, or I shouldn't say we because I wasn't around then, but it got removed without having a replacement. There was just, I don't know, optimism or faith or whatever that something better would arrive. And this was about the time when I started playing with IPv6 to test, to see what everybody was talking about, or some people were talking about anyways. So when the new PF came in, I thought, wow, I'm doing v6 stuff, it would be cool if it supported v6 too. So I wrote it, and that's how I got started. So these are the design rules kind of basically in order of importance. The most important thing is the license. If it hadn't been for the license problems with the previous packet filter, we might not have gotten around to writing our own. It was kind of working good enough for what we were trying to do. Next goal is to be secure, robust packet filter. I mean, that's what the software is supposed to be doing. It's a security tool that needs to be secure. In general, we like to have readable code, so code correctness and maintainability, readability are important. It should be flexible but easy to use. So a big problem is in packet filters, in firewalls in general, is that there's a lot of specific options and little buttons and knobs that you need to tweak. But we want to also make those optional so that if you have a simple use case, you can only use the simple parts and ignore all the complicated stuff about load balancing or whatever. And the last thing that we were concerned about, and still really the last thing that we're concerned about, is performance. There's some performance impact to security, so it's not like we don't care about performance at all, but it's not the most important thing for us. And now PF is about 37,000 lines of code, more or less. PF.c used to be the longest compiling file in our kernel, but I think we moved a lot of the code out of PF.c into a separate file, so it might not be the biggest anymore in terms of compile time. Yeah, still?
Yeah, I think so.
I'm not going to give a complete list of all the things that are wrong, because, well, that would be boring. We don't have forever. And also, I don't know all the things that are wrong. All code has bugs. All code is horrible. I don't know of any really, really good code. I know of some pretty good code, but nothing that's perfect. And so this is definitely in that category of imperfect code. So I don't even know what all the problems are. I'm just going to talk about the big ones. I'm going to talk about the architectural problem and some general code quality problems. And I'm not going to talk about bugs at all. I'm talking about PF in OpenBSD, FreeBSD. There's been a lot of changes since 2007. I spoke about them when I was here then, and that's basically what FreeBSD has now. The code from 2007 is what is PF in FreeBSD. So I'm going to talk about what we have currently. I'm going to talk about bugs. Bugs happen in code where people don't use the code. And where the code is very complicated, but people actually only use a small part of it. So in PF, there's anchors code. You can do crazy things with nested anchors and inline anchors. Anchors is a mechanism for sub-rule sets. So if you have a rule set, you can call a sub-rule set out of that. We call that anchors. And there's lots of stuff you can do with it. Most people have a single rule file, and all their rules are in one place. They don't use this feature. The user-oriented kernel interfaces, the IO control interfaces, there's functionality in there that nobody actually uses, like the ability to modify rules that are actually in the kernel. The binaries that ship with OpenBSD don't use those features, so I'm certain that there's bugs in that code because nobody uses it. IPv6, there's definitely IPv6 bugs in PF. I was told of recently discovered one this morning. So we have to keep this problem in mind when we make design decisions and we add new features. We have to think, is there going to be a use for this? It might be a cool feature, but if only 0.1% of our users are going to use it, and of those people, maybe 1% of those people are going to tell us if they find a problem, that's probably not a good feature to include. I do know that all the bugs in PF are in code that was not written by Mike Fanson. If you look at the code, the commits that he makes, I think he's made like a dozen commits to PF. They're all like entire files of code, and he never makes any bug fix commits. The code is correct when he commits it, and that's it. And if there's any bugs in his code, it's because someone else added one in afterwards. It's really amazing. He deserves lots of credit for the code that he's done. And the comments in his code are amazing. You look at the state handling code for TCP or the TCP scrubbing code, and there's giant blocks of comments explaining exactly why he's implemented this way and what the problems are with the RFC and why we're ignoring them, that kind of thing. So very good code, and I wish I could write code that well. How do we operate? We try to do evolution, not revolution. We don't fork our tree and have a development branch with a new version of PF that's going to get merged back into the main tree 3 years later. All the commits are done to the main tree, and we try to make small changes that can be tested. And this means, because we have a release cycle of every 6 months, this means that the size of a change is limited. The most you can do is a change that can be committed, tested, debugged, and fixed, or backed out in 6 months. So anything that's going to, a bigger change than that has to be broken up into chunks that are independent in order to get the change done. This means that we're less invested in an individual change. If the change breaks, we can back it out. We don't have this major change in functionality at any single point. We keep the system so that it's always building. Sorry. Rolling forward to new versions is easier when you're jumping releases. Hopefully not much has changed. Now, the 4.7 release is an example of a release where there's a lot of change. I'm glad Bob's not here because he would really yell at me right now.
I can fill in for Bob.
It's too rude.
Do it.
And it means that other subsystems stay integrated. When I'm talking about software quality in general, there's a wonderful ISO model for software quality. It's not really the model that we use. It's got a couple of numbers because ISO likes to change the names of their standards so that they can sell it again. So we're talking about like functionality, reliability, usability, efficiency, maintainability, and portability. Those are all kind of corporate-oriented goals, and they're important. They're not all of it for us. What about the beauty of the code? I know there's, like seriously, there's some code that I think is very beautiful in PF, and some code that I like close my eyes if I accidentally look at it. So this is important to me as a developer, and I think the quality of code everywhere would be better if developers thought about that when they're writing code. Not just how the code looks, but also the beauty of an algorithm that you choose. I think there's a similar effect in mathematics. People or mathematicians can know whether a formula is a beautiful formula or not, or a beautiful proof or not. And this is similar in software. ISO doesn't care about software licenses. And we really care about software licenses, so that doesn't fit into their model either. And we care about having fun. We want excuses to hack. We want excuses to go hiking, and we want an excuse to drink beer. So that's a big motivator in our code as well. I'm not really qualified, clearly, to talk about aesthetics because I can't make beautiful slides. So, as far as aesthetics, we've always got cleanup just in terms of the kernel normal format or the style of our code. Developers really get used to the formatting style of our code, and if you find code that's not matching that style, it gets hard to read when you have a lot of nesting or complicated if statements. If it's not formatted the way we expect, it's harder to see bugs. So a lot of people, when we take legacy code and import it into OpenBSD and we format it, we find bugs just by formatting it, finding, indentation, fixing indentation, and finding that an if statement doesn't have brackets around it, so the if only applies to the first part of that block of code. So there's a bunch of stuff in there that's maybe more structural that I noticed when I was working on stuff in Melbourne. We have a structure called PD that passes data about the packet around PF, but that was added late in PF's development, so it's not used consistently. So some parts of the code look at that, some parts of the code look straight at the packet to get their information, and that can cause problems if the PD structure gets updated and the packet doesn't yet. There's some type inconsistencies. I'm sure there's some space either for some bug fixes or some data savings in the data structures by checking, we're using int when we should be using like a byte to save the address family, for example. And like some structures change a lot as we add features. The PF state structure and the PF rule structure are like the core structures of PF. And as we add features, we add flags or remove flags or change things around. And sometimes the old variables that are in those structures don't get removed, or they could be merged with something else. And I think there's a lot of work to be done cleaning that stuff up. There's some more complicated things in the code that are, they were done that way when we imported them, but maybe they need to be rewritten. They haven't aged well. The tables code, which is used for matching lists of IP addresses in the rules, it uses the Patricia tree code from the routing table, which is 40-year-old code, and it's really, really nasty. It's all these callback functions, and basically it's territory that you don't really want to look at if you don't have to. There's also some performance problems with the Patricia tree. So we'd like to maybe re-implement that with a PF-specific version. There's all this kind of crazy buffer code for passing data between userland and the kernel, and it's very difficult to work with. It creates problems when we're trying to do space savings. For example, we would like to have, not all states in the state table require the same amount of storage. Some of them are very simple and some of them are very complicated. And we would like to be able to pass around different size state structures depending on what that state is for. So we can save space, because a busy firewall might have 300,000 states. If you have a lot of connections, then that has a big impact on memory. So we want to save space on the state structure. Right now, the buffer code forces you to have identical sized structures when you're passing back to user land. So it's a little bit, it makes it harder for us to implement some space savings. And in the user land side, the handling of anchors is just horrible. It's kind of layers of code that have been grafted on. That's my fault. I wrote that code. Actually, all these complicated things are things that I've either written wrong in the first place, or I've committed to Henning that I'll fix, and I haven't done yet. So it's all my fault. So pf.conf, the syntax is kind of, in theory, LLR. We use Yak. It was initially based on the IPF syntax, kind of just momentum, I guess, partly because we wanted to make the transition easy for users, and partly because writing a syntax, like a new parser syntax, is actually really hard to get right. And I think at some level, the developers kind of were like, well, we have this, we already know it, let's just implement that now and we can fix it later. Didn't really work out that way. So as we added features, people just pick a keyword and we try and make it fit in, but it kind of grows organically over time, and a lot of the changes were made by people who don't necessarily understand how Yak works. I mean, I don't understand really how Yak works. So the code, the parser became more and more brittle, and as we try to add features now, it becomes more and more difficult. It's kind of confused now whether it's a line-oriented parser or like a parser like C, for example. Like, so is it KSH or is it C? We have these single line rules, but then you can have these blocks of rules. So Phil is trying to fix some of this stuff, get rid of the annoying braces and lists. Macro expansion is crazy when you're trying to expand lists of macros, or lists of addresses, that kind of thing. And he spent 2.5 hackathons at least trying to fix this problem. Basically, host names are converted to IP addresses at the wrong place in the lexer, and or rather, they should be done in the lexer, they're done in the parser. So it's very hard to fix, and it's even harder to fix with IPv6, because IPv6 addresses can be encoded in about 1 billion different ways, and we need to support at least 3 or 4 of them.
4 billion, or?
We can maybe make some improvements by removing features or replacing them with better designed ones. We kind of backfired sometimes on this. For example, we were trying to get to a route to. There's route to, reply to, and dupe to command options in PF that allow you to override the routing table. And they cause all kinds of problems internally. So it would be nicer if we can remove those functions, especially Henning would like to see them go. So now we have route to, and we have alternate routing tables. So you can select a separate routing table in PF and do routing based on that. And we have routing domains. So you can, kind of similar to alternate routing tables, but more strictly separated. And we still can't remove route to and friends. So we're stuck with it. And I don't know, are we going to add more different routing options? Maybe the next routing developer who comes will have their own idea. And
for IPv6, not 6.4.
Oh yeah, that could be another one.
That's another one.
As far as performance, the best case performance has improved a lot. We've made a lot of changes. I'm not going to go into the details of all of those changes. If you look at Henning's talk, who's the guy that's doing a lot of this work with me, he spoke at AsiaBSDCon last year, and he went into the details of his performance changes that he made. The worst case performance is still a problem, and there's not really much you can do. If you're getting a lot of very small packets, you're going to get hosed. You need I'm guessing, I haven't really measured, but I'm guessing you need to be able to handle about 10 times as much traffic, of good traffic, as you're expecting to get attack traffic. So if you want to handle a 100 megabit link, you need a box, a firewall, that's capable of handling a gigabit of traffic to be able to handle an attack correctly. There's kind of two cases here. One is attack traffic that you can block. That's easy. We can maybe improve the packet filtering, or you can maybe put some hardware in front, some hardware-based router with ASICs on the individual network ports that can block some of the traffic. If it's traffic that would normally get passed, say you're getting a SYN flood to your web server IP address on port 80, you don't know if that's a legitimate SYN packet or not. You have to allow it through and create state. It's much more difficult because now you have a CPU attack that's also exhausting all your memory by creating states. And there's very little we can do. You really have to push that kind of mitigation upstream. You have to get your ISP and your ISP's ISPs to help you counter those kinds of attacks, maybe with routing, for example. Portability. Within OpenBSD, portability is really great. I don't think we've had any real PF bugs that have come up. A cross-platform issue on OpenBSD. When we port it to new architectures, it works. Developers have to use at least an i386 and a Spark 64 when they're testing. And anybody who looks like they're going to be doing a lot of development gets told that they should get a Spark 64 to test on. There's a bunch of the portability issues, alignment, pointer size, endianness, the requirement to use copy in, copy out, moving between the user land and the kernel. All these things are different between i386 and Spark 64. So that catches like 99.9% of the developer errors around portability, and we haven't had very many problems. The other OSs, it's pretty good. We have FreeBSD, NetBSD, macOS all have ports of PF that are working. There's a port to Windows if you've used CoreForce that's based on PF. But it's getting harder because in OpenBSD we're moving more to integrate PF with other subsystems within the kernel. We're tying it into the TCP and UDP stack. We're tying it into the routing table. So it has more and more impact on the rest of your kernel, so it gets harder to port it. And I think that's a big reason why PF hasn't been updated lately in FreeBSD, that there's problems with where to put the locks for FreeBSD, whereas we don't have that problem right now. We have a big lock on the whole kernel, and PF doesn't need to know anything about locking. So this is an uglier version of the diagram that Simon showed 2 hours ago. Basically, you have a computer running OpenBSD, a packet coming in on this side enters IPv4 input, goes down to PF test, and then back up to IPv4 input, gets passed through the routing, and then IP output, and then PF test, and then back out. So PF gets called twice. You can skip the PF test on one side by having PF ignore that interface completely, but most implementations, most firewall setups will have it running twice. So we used to use mbuff tags on packets to pass data about the input path into the output path, various tags and flags and stuff for PF. We converted this to just sticking it straight into the mbuff. I don't think that FreeBSD has done this. I think what you guys have is from before this change. So we just used a bunch of, a little bit of the mbuff header space to add PF data. In the real world, most packets coming from the network card are on an mbuff cluster, so they have their own space for the actual packet data. So the space that's free in the mbuff itself doesn't get used anyways. So it's, in the real world, this is free as far as space in the mbuff, but there's a huge performance savings. You don't have all this malloc and free going on for these mbuff headers, plus it's just in a linked list. So if you have a bunch of, the mbuff tags, the mbuff tags are in a linked list, so you don't have to walk this linked list every time to find the tag that you want. And it made a huge difference. I don't know exactly the numbers, depends on how you test, but like double the performance, basically, by making this change. There's a bigger change that's almost finished, but this is an example of a change that couldn't be done in one shot because we didn't have the confidence to do, or the time to do all this work in 6 months across one release. So it was planned out early on and then implemented in chunks over time. The state table is indexed in a red-black tree, like a binary search tree, and it actually used to be kind of like a forest because you can have states that are bound directly to an interface, or you can have states that are bound to a group of interfaces, or you can have states that are global for the whole system. And normally, the states are global. But you still have to check to see if there's any interface-bound states first. It's kind of a nasty setup. So the initial goal was to improve the end-to-end connection tracking. There are a bunch of systems in the kernel that do lookups based on the IP addresses, the tuple, you know, the source and destination IP address, source and destination port, the address family, the IP protocol, that kind of thing. So we're doing this early in PF. Why can't we use that information later? You notice also we're doing PF twice, on the inbound and on the outbound path, but the packet is often the same. So how can we link that information from the inbound path to the outbound path and skip the lookup on the outbound path? That was the main goal, was to basically a performance improvement. We were looking for ways to reduce the performance load of the state table lookups. This is going to help the throughput for regular traffic that you want, but it's not going to really help your performance under attack. There's a bunch of things that we improved kind of along the way, just as a part of this goal. It weren't really the goals, but they got implemented anyways. We had protocol-specific copies of the functions that do the rule set lookups. We merged those into one and saved about 10K in the kernel of like binary file, not source code, but 10K of code, and improved performance by 10% or something like that. Just based on probably the cache. Reducing the amount of code that's in the cache, you get better performance. We improved the state creation code a lot. There was a lot of error conditions that weren't getting checked or getting checked incorrectly or not handled correctly, and we cleaned that up a lot because it mostly had to be rewritten in this work. We fixed the handling of IF-bound states. We tried to simplify the syntax of the rules by moving functions that were different kinds of rules before, like scrubbing and nat, were separate types of rules, and now they've been moved into actions on regular rules. This improves the syntax. It makes new syntax, new behavior possible later on. It's not all implemented yet. And it also improves performance, because you used to have to look into the scrub rule set to see if there's any scrub rules, and then into the nat rule set to see if there's any nat rules, and then into the main rule set. Now, you just go into the main rule set, and if you hit a scrub rule, then you scrub. So in the Dark Ages, you kind of had a bunch of different state trees. And the state structure looks kind of like this. And you have to search 3 times, basically. You search for the interface, you search for the interface group, and then you search the global state table. So even if you don't have any interface-bound states, you're still searching to see if there might be one. So the first change was to separate the state key, which is the part of the state that we actually do the lookups on, the IP addresses and the port address family, that kind of thing. Separate that from the connection tracking part of it. So the the TCP sequence numbers, the packet counters, whether we should do routing or NAT or that kind of. NAT is not included, but routing is included in that. And then we put those on a linked list. And if you only have global states for a specific state key, you only have one item on the list. It's very fast to check. The list is sorted, so you would have the interface-specific states first in the list. You'll find those first if you're looking, and if you don't find one, then it's a global one, and there's only one on the list. The next change we did, which we talked about the terminology and how it started becoming a problem talking to each other about it, and I think Simon talked about that a little bit, that maybe we need a new change in terminology to handle the NAT64 code. But the next change was this distinction between the wire side and the stack side. So the wire side is the flow descriptor, the tuple, the IP addresses and ports and everything, as it appears on the wire going in or out of the box. And the stack side is what appears to the core, the routing core, after PF has done its operation. So we have the state key, and then the state points back to the state key, which with a wire side and a stack side key. And if you're not doing NAT, these are the same. With NAT, you have 2 different state keys. One is how the packet looks before you apply NAT, and one is how the packet looks after you apply NAT. And you point to the 2. Now to decide if NAT is taking place, you don't have to do any address comparisons or look at any flags. You just check those 2 pointers, the state key wire and state key stack. If the pointers are the same, you're not doing NAT. If they're different, the structures are different, and you're doing NAT. There's nothing that says that the address families have to be the same. So we make use of that for NAT64. You can have a V4 address on one side and a V6 address on the other side. A little bit more complicated than that, but. So next thing I want to do is save a pointer to the state in the inbound. So on the inbound path, we save a pointer to the state, and then on the outbound path, we can just look at that pointer to see if we already have a state, and we don't have to do the lookup at all if we already have a valid state for this packet. So in the forwarding case, you will have 2 states. You'll have a state on the inbound interface and a state on the outbound interface. And you'll have this kind of cross-linking between the two state table entries. Now, the states are cross-linked in both directions and associated with the packet properly. We can tag other things in there. You just put it into the state. We don't have to add to the MBUF header anymore. We can add pointers to the TCP and UDP PCBs. These are for connections that terminate on the firewall itself. We could do routing lookups. That's not implemented yet. IPsec SA lookups, not implemented yet. Maybe some other things like the connection context for MPPD, which is kind of, there's a kernel part and a user land part for the PPP doing. So the kernel part could make use of the PF states to avoid doing extra lookups. Unfortunately, this formatted wrong here. Maybe my screen is bigger. So this was initially conceived in May 2004. Henning and I were on the ferry, and it started out after the PF hackathon in 2004, and it started out kind of as a discussion of, hey, what could we do? Oh, this sounds cool, let's do this. But when we started talking about what would need to be fixed in order to get there, we didn't want to touch it. So we didn't touch it for a couple of years. We made some agreements, mutual agreements about who would do what pieces as far as the cleanup, and we kind of worked on it on and off. Initially, we thought that we wouldn't be able to implement the state table linking with the route to functionality. So we thought that we would have to kill those features in order to implement this bigger project. So one of the first things that was implemented was alternate routing tables with a view to using that mechanism instead of the in-PF routing overrides. So that was done early. We did the basic split of the state structure and then fixed the interface bound states. That was done at the general hackathon in 2007. Some of these things were done a lot earlier than when they were committed. Some of these projects might have been actually implemented 5 or 6 months earlier, but couldn't go in for a very complicated change in OpenBSD. Generally, it gets implemented before the tree locks, and as soon as the tree unlocks, it gets committed, and then we have maybe 4 months to decide whether we're going to back it out or not. After some point, it becomes too dangerous to back it out and you're committed, you have to just fix the bugs. But there's a time period where you can run something, and then just before the next release, you decide, we're still not confident, there's no bugs in this, we'll remove it. And that happens fairly often. I guess that there's a couple of things every release that get backed out just before the release is made. An example for us, when Henning added in 2008, when Henning linked the PF states to the TCP PCBs, there were problems. We started finding exception cases for tunnel interfaces, and we'd fix one, and then there would be another one, and we'd fix another one, and there would be a third one, and then right before the release, we just decided, look, it's a couple of lines diff to just disable this functionality for the release, and we'll turn it on again after the release and fix it then. We're not going to, ship something that's potentially not working for a release. There's lots of examples, I think it happens a lot in the file system and the SCSI code where things get put in and then backed out right before the release. Except for the alternate routing tables, which we didn't really need to implement for this, and hopefully we will remove someday.
We need them.
Do we?
Yeah, the R domains are alternate routing tables as well.
Right, but do we need 2 alternate routing table mechanisms? We have disagreement within our project. New developers who come to our hackathons are often surprised at how loud and how seriously we disagree with each other. It's a problem. And it's related to the size of the developer.
That's because Paul's not here.
I'm looking at you.
I haven't been around for a few years.
There's some unfortunate side effects to the stuff that we've done. The new model of states, those crazy diagrams with the links between the state keys and stuff, I didn't even show you the one where Matt is involved with states on either side. And I don't think you can draw one for NAT64 on a single piece of paper. I think it requires a 3D or a 4D model. So it's hard to work with. At any point in time, there's maybe 2 or 3 people that actually understand how it works. And when we go to a hackathon, we find the person who understands and get them to explain it to the other people again. There's some fortunate side effects as well. We can do NAT and RDL on both directions now, or we can. Previously, you do redirects on the inbound path and NAT on the outbound path, and we have the capability in the kernel to do NAT on the inbound path and redirects on the outbound path, which can be useful in some situations. For example, when you're trying to join 2 address spaces and mutually hide those address spaces. So if you're doing like a corporate takeover and you want to bring the other company into your network, you don't want to renumber, you don't want them to renumber, you just want everything to work. You can use that kind of functionality to merge them more easily. What was that?
I'll show you
That's not. It's just this. It's supported in the kernel, it's just disabled in the parser. It would be really easy to support it, but there's some problems with routing when you do that. And we need to decide, is that just a documentation issue? Do we need a little bit more features in PF to link the routing to automatically do PF overriding the routing in those cases? We're not quite sure what to do. So in these cases where we could add functionality, but we don't need to right away, we generally wait a bit just to see where things are going to go. Because once we add the feature, it's very hard to remove the feature. Everybody complains. So we try to be conservative about adding new features in the parser. Debatably, it's debatable whether this is fortunate, and it's debatable whether it's true, but the new state table may have made NAT64 easier to implement. The jury is out on that. We need to figure out how we're going to go ahead with that. I mean, it works, so I guess that's good, but we might want a different approach. More performance optimizations, something that we want to do. I wanted to talk a little bit about performance differences between FreeBSD and OpenBSD, since there's so many FreeBSD people here. I spent a week or so doing testing, and previously, when we talk about PF, we talk about performance with the gear that we use when we're developing, which is usually little boxes that can be killed by traffic generated on a laptop. So we use SOCRIS boxes, if anybody's familiar with those, are the little green things with like a 200 megahertz 486 CPU in them. Very easy to knock over with a laptop generating traffic. So they're nice for testing. It's really nice. You don't need a big test setup or lots of gear to be able to check whether your code improves the performance or not. But it's not. They're not really. Well, at least in Japan, you can't use those in the real world because even at home, you can get much more traffic on your home internet connection than you can handle with SOCRIS. I guess they're still usable in the third world, like Canada. So, yeah. So I didn't want to talk about how the performance is improved on ridiculous hardware. I wanted to talk about semi-real hardware. So I was doing gigabit performance testing, and it's hard to do gigabit performance testing without real testing hardware like $100,000 network traffic generators. Because it's just really hard to generate streams of small packets. So I had a whole pile of boxes set up, and I spent way more time setting up my test environment than I did actually testing. Now I have some preliminary numbers, and I'm going to work on this some more and hopefully have a lot more hard details for my talk next year. Basically, talking about a dual processor, 1.3 gigahertz machine. It's an old machine. It's a compact before they granted their servers, HP DL 380 G2. So it's like a, what is that, 6 years old, 10 years old machine now?
5 or 6, 10.
G2.
10 years old.
Yeah, 10-year-old piece of hardware. But it can handle a gigabit of like optimal traffic, TCP connections with full-length TU packets. And on OpenBSD and on FreeBSD, we can handle a full gigabit of TCP sessions. I had some problems. Maybe somebody after my talk can tell me how to disable SMP on FreeBSD. I don't know how to do it.
It's just an option in kernel. You take away the option.
Oh, I have to compile a new kernel. I don't know how to do that on FreeBSD yet, so I'll have to Google that.
Bad deals.
Yeah, I'll check that. I didn't have a lot of time. So I did testing without doing any optimization on FreeBSD or OpenBSD because I didn't know how to optimize FreeBSD, and it wouldn't be fair for me to optimize OpenBSD, and there's not really much you can do anyways. So I just did stock installs, and both handle gigabit without PF. Once I enable PF with a single rule that just says pass all the traffic, it's going to do state lookups. But it's just going to pass all the traffic. You're not really doing filtering. On FreeBSD, the throughput drops down to about 550 megabits of traffic. Both CPUs are almost maxed out. You're dropping some packets. I think the idle is about 11%. On OpenBSD, we get similar throughput. Now, if I run it with dual processor, like multiprocessor mode on OpenBSD, because we have the big lock doesn't buy you anything on kernel code in OpenBSD, or SMP doesn't buy you anything on kernel code. So the performance is actually worse, and the interactive performance is horrible. I couldn't even run diagnostics on the system. We were still passing the traffic. The kernel is running full blast in kernel mode, moving packets from one interface to the other. So it's doing its job, but you just can't log into it. But when I put it into single processor mode, the performance is about the same as FreeBSD. So our single processor OpenBSD is about the same performance as FreeBSD. I think the throughput performance was about 93%. So FreeBSD was doing 550 megabits per second. OpenBSD was doing 520, 519 megabits per second. The latency on OpenBSD was about half. So FreeBSD is taking about 5 milliseconds to move packets across under load, and OpenBSD is taking about 2.5 milliseconds to move the same packets. On identical hardware, everything's identical except for the OS. We have some performance improvements to make on our transmission side of our interface outside of PF, and we're hoping to get some more improvement in the latency. Clearly, we have some scalability issues when it comes to multi-pro, and I don't know. Some of it is going to involve changes in PF, because even though FreeBSD is able to handle interrupts from different interfaces on both of its cores, it's still got a big lock around PF. There's a single state table, and only one kernel or one core can be doing PF operations at a time. So if FreeBSD wants to scale the PF performance, they're going to need to have some finer grained access, but so are we. That's something that I'm looking at doing, looking at like lock-free data structures that we can use for the PF state table. There's a lot of just cleanup that needs to be done. I'm hoping that maybe for the next couple of releases there's no giant diffs. So I think we need to work on the NAT6.4, because I think right now it's a giant diff with a 3,000 line diff. I prefer to deal with like 3-line diffs. So we'll work on that for a while. We need a lot more documentation. I think for users it's hard because they don't understand how the internals work, and we have OpenBSD developers who are furious with me this release coming because the rule set structure has changed and they don't really understand how it's supposed to work now. And the documentation is just not there. So we have some work to do in documentation. It's hard for somebody who's actually making the change to do that, because you're kind of like, you know what you're doing, you see the change that you made, you know how much better it is, and it's hard to see how somebody else who's just coming to the change, or especially is used to how it used to work and is now just trying to figure out how to make his old thing work now. It's hard to document that clearly for people. So we have some work to do there. And I think we need more developer-style documentation. For example, every hackathon that we go to, we end up drawing on the whiteboard like this. And it would be nice to have like a big diagram of how the state table works, so that we can just post up on the whiteboard and not have to spend a lot of time with the pen. Hanging there.
That's a joke.
The clown? Or the cloud? So we need good code, especially easy to understand code. We don't want more complicated code, and bug fixes are good. And obviously the usual, please give us money. It buys hardware and sends developers to hackathons and makes more of this kind of stuff happen. Maybe the FreeBSD Foundation wants to buy some hardware, test hardware or something like that, so that we can improve PF and you guys can get a newer version that works. It's your code too now. The documentation, if you run into something that you don't understand and you figure it out, if you can document it, we'd like that documentation for the man page or for the PF FAQ. You guys especially, the FreeBSD online documentation for PF points to the OpenBSD PF FAQ. It says, OpenBSD does a good job of documenting PF, so look at their documentation. And it's true, the FAQ is really good, and some of the problems that I've talked about with documentation will be fixed in the FAQ when 4.7 is officially released. But it's documenting OpenBSD's released version of PF. So it's no longer documenting anything like what you guys have in FreeBSD. So you guys either need to write your own documentation or update your PF to OpenBSD current, one of the two. Any questions? Heckles.
Yeah, it really sucked at the change on my firewalls.
Yeah?
It was awful for me because I had an array of firewalls in my lab and it blew. It took me days to get it all figured out. Because there were so many rules, so many routing tables, so many things that were just different. So that NAT change was a big deal.
I think that's definitely the biggest change that we've made as far as the user side of the experience.
As bad guys, actually.
Yeah. Well, we could do worse. Do you want worse?
No. For the years, I always concurrent, right? So this was as bad guess for me to get my environment basically. It's not. I mean,
and it's a problem because we have a lot of developers who are actually willing to run their code in production. So there's really crazy people like Bob Beck or DLG who have, they're working at a university and they'll just throw a test code into their production. We have good failover support on OpenBSD. So, so what if the kernel panics? It switches to the other firewall and then we'll back the code out and try it again. But those people are not as willing to do those kinds of tests when there's a big functionality change. It is a problem, and we really want to avoid making these kinds of changes if we can. But there was just no other option. I did talk to people about having the PF control parser understand both formats, the old format and the new format, and it's doable, but it kind of just defers the problem.
Sure.
And that people won't.
No, so the real issue was the documentation issue, right? Because you guys literally had a one-line example that just did not cover the reality, right?
Yeah.
So sure, that'll work fine for my home firewall where I have to set one rule, but anything more complex than one rule, and it fell apart. I mean, again, that's been days just figuring it all out. Because I don't touch that data stock, right? So I look at it when I'm doing a new release and there is actually changes in BF. Well, right?
I think the flexibility from the match model as well really makes it a lot more complicated, where you can have a lot of different things happening, right? It's not just like final anymore. You've got your NAT rule and it's happening at one point. It can happen anywhere in your rule set, and things can leak through, and then you have to figure all that out. So
we're aiming for Turing complete. We're not there yet, but we're close. Who has support for BPF, filtering in PF? Was it Reich that has? Reich has a patch that so you can write BPF filters in a specific rule, and it will use BPF.
That's
Stick it wrong.
That's wrong.
It's not Turing complete. It's still not Turing complete.
Maybe
BPF plus? Yeah.
Can we get Unix to put the tiny list into PF control as well? So it's acceptable in the PF. So
we'll think about that.
Yeah.
Talk about it in
All fifth.
So Ryan,
Yes.
you know that there are problems, and the release is not out yet. Is it really too late to do some more documentation?
No, it's not. We still have a couple of days to. Pardon me? Pardon me? I think it sounds like no. There's lots of time to do documentation in the FAQ. That can be updated anytime. There's no lock on the FAQ, so that will be updated.
The man pages are updated.
The man pages are updated, but people are having a problem with it. And it's not that the man pages document the functionality, but I think that there was some inertia when we first wrote the man page that it was kind of like the code works the same way as IPF, so everybody already knows kind of how it works. So people who already had experience with IPF and read IPF facts knew that PF is going to be mostly the same, and so the documentation was understandable. And if you don't have the kind of meta knowledge that you understand from hacking on it, the documentation is not apparently understandable. To me, it's understandable, but I acknowledge that people who weren't hacking on it can have problems, even people who I would consider experts with PF, like Bob Beck, who was really cursing me the other day. So, yeah, we'll work on it. Sorry, everyone. Freebie, I think people can be happy that they're not tracking PF and OpenBSD really straight. Maybe the documentation will be better in the next release. Use that instead.
It is much nicer now that I figured it out.
Yeah, you like the new functionality.
Right.
Yeah.
It is great, but yeah, again, just switching it all over at the same time, blue.
I think that's it. Any other questions?